In Lesson 4-2, we're going to move forward in solving systems of linear equations and discover that there are additional methods, and especially if you end up with more equations and more variables than just two, this is going to be a very helpful thing to know. Particularly if you're working in business, you may have a number of equations that you're having to take into account because you may have not only supply and demand, but you may have overtime expenses of employees or utility expenses, all kinds of other factors that could get rolled into creating a much more complicated scenario in terms of trying to find what would be the target value that you're looking for. So, if we put things in the form of a matrix, and a matrix simply means that we have organized our coefficients into rows and columns. That's all that it means. We have some things that we are permitted to do with matrices that won't break any algebraic rules. For example, once I have my matrix set up, if I want to switch two of the rows, I can do that. It's just like instead of putting one equation on top and the other one on bottom, I can switch those and put the second one on top and the first one on bottom, and that's not going to create a problem. I can also multiply any row by a constant, and that is a legal thing to do in algebra. As long as I'm multiplying both sides of an equation by the same number, then I haven't broken any rules. I can also multiply a row by some constant and add it to another row and then replace that row with what I get. Now, it's probably easier to understand if you actually see this in practice. I'm going to give you illustrations here. Again, the funny looking eye things in the front, don't worry about those. Those were braces originally that just didn't print out with the correct formatting. But let me explain how you're going to write something that's written in equation form and put it into matrix form. So that's going to be our first step. Remember how I said we're going to have rows and we're going to have columns. Our rows will correspond with how many equations we have. So for this particular example, there are only two equations. I'm going to have two rows in my matrix. My columns will correspond to the variables that I have in the equations, and my very last column will always be my answer column. So what we do when we create a matrix is we use squared off brackets, and we don't include any variables in our matrix. We're only going to write coefficients. So if I go across the top row, my coefficient in front of x is 1. Remember, if I don't see it, then I know that it was 1 times x, and that's going to mean my coefficient is 1. In front of the y, my coefficient is a -1. And then my answer for that equation is a -1. In my second row, my coefficient for x is 3, my coefficient for y is -1, and my answer for that equation is a -1. Now I'm going to close off the brackets, and to make sure I don't get confused, here's what we do when we write this matrix. We're going to put a vertical line separating the answer from the variables. In other words, where the equal sign was in the original equation, we'll put a vertical line there so that I know what's on the left went with variables, what's on the right was the answer part of those equations. Now what I'm trying to do is I want to reach a point where my final matrix, okay, what I'm looking for in a solution, my solution matrix, should have 0 for the first entry. I'm sorry, I thought I already had written down the 1. Let me correct that. We want a 1 in the top row followed by a 0. And then we'll want to have a 0 in the second row followed by a 1. What you're looking for is a solution that will have 1s on the diagonal starting from the top left. So we have a 1 on the top left, we have a 1 on the bottom right, and then whatever we end up with over here will be our answers, because remember, this first column was our x values. This second column was our y values. If we were to put that back into equation form, that would be like we said, 1x plus 0y equals something. Well, that's going to tell me what x is. On the bottom row, I would have 0x plus 1y equals something. That's going to tell me my y value. So that's how we'll read off from a matrix. Now, I already have a 1 in the top left of this matrix. That's good. So I don't have to do anything to the top row yet. Once I have a 1 in the top left, I go to the next row, and remember, I want this to be a 0. Now, in order to make that a 0, I can't multiply that row by 0 because it would turn everything to 0. If I'm multiplying through by a constant, it has to be some number other than 0. So instead, I'm going to multiply the top row by something and add it to the bottom row to create my new bottom row. And so the top row is row 1, the bottom row is row 2. And here's what you're going to tell me is, what operation are you doing? Well, if I want to multiply this top row times something and add it to the bottom, and I want that to end up being a 0, I need to multiply the top row by -3 and add it to the bottom row to get my new bottom row. Now, nothing's going to change on my top row. But on my bottom row, if I multiply -3 times 1 on the top, that gives me -3 plus 3, which is where 0 will come from. Okay? If I'm multiplying -3 on the top row, -3 times -1 right here would give me a +3 plus a -1, which is going to be a +2. And then I have to do the same with this term. So I'm going to multiply a -3 times a -1, and I'm going to get a +3 plus a -1, same thing I had here, and I'm going to have a 2 there. All right, so here's what we've done so far. We've gotten the 1 in the top left row. We have a 0 now in the bottom left. I need to turn this 2 into a 1. That's the next thing that I have to do. Now, I can have options. I might want to multiply that row by something, and I could turn it into a 1 that way. I want to be careful though, because if I try to add the top row to the bottom row, I'm going to mess up that 0. So I really don't want to do that. I need to figure out what I could multiply this bottom row by to turn that 2 into a 1. Well, that's going to be a 1/2. So if I multiply row 2 times 1/2, that's going to be my new row 2. My top row is still 1, -1, -1. But if I multiply through by 1/2 on the bottom, 1/2 times 0 is 0. 1/2 times 2 is 1. And then 1/2 times 2 is also 1. My bottom row is done. Now I'm going to try to get a 0 after the 1 in the top row. Notice we're kind of making a loop here. You start with the top left, move down to the next row to get 0s until you get to the where the 1 needs to show up in that row, and then you'll move to the row below that, and then you'll come back up to correct anything that's not a 0 excuse me, that should be. So it looks like I could do what to turn that -1 into a 0? Well, I can't multiply that row by something to make it 0. Remember I said if I'm trying to make a value 0, I'm going to have to multiply the other row times something and then add it. Actually, I don't even have to multiply the other row in this case. What's going to happen if I just add these together? Well, exactly what I want to happen. Row 1 plus row 2 is going to be my new row 1. So if I add 1 plus 0, I still have 1, top left. If I add -1 plus 1, I get 0. And if I add -1 plus 1, I get 0. And my bottom row was 0, 1, 1. That means my solution is the ordered pair 0, 1. Now, how in the world would I know if I actually did this right? Well, just like we said on substitution and elimination, we can go back and put these values in to one or both of these original equations. If I go to x minus y equals -1, and I put in 0 for x, and I put in 1 for y, 0 minus 1 is a -1, and -1 equals -1, it does check. So if you look at this example, it's very similar to the one that we just did. Let me remind you, our goal is to end up with a matrix that is 1, 0 on top and then 0, 1 on bottom so that we can find these solutions for x and for y. So if we put this into matrix form, our top row, in fact you might want to pause it just a minute to make sure that you're writing this down correctly, you understand. If not, you may want to do that on the next one before you see what I've written down. We're going to have a 1, a -1, and a -4 when we take that top equation and we put it into matrix form. The second equation becomes 7, 5, -4. Now, remember we start top left. We want to make sure that the top left entry is a 1, and this one is, so we don't do anything else to the top row yet. When we look at the bottom row, I need that 7 to become a 0. If I'm trying to turn something into a 0, I'm going to have to multiply another row by something and add it to that row. So the only way to turn that 7 into a 0 is if I multiply -7 times row 1 and I add it to row 2, and that would give me my new row 2. Now these notations that I'm writing out to the side with the arrow and the R1s and the R2 are important because what it shows me is what row operation you actually did on your matrix. And especially if you had any kind of mistake that you made with adding or subtracting or multiplying, I can probably give you some partial credit as long as you showed me that this was the row operation you were trying to do. So make sure you write down all these steps. I'm going to be looking for that on your test. So our top row is still 1, -1, -4. But our bottom row will become -7 times 1. That's -7 times row 1 plus row 2. So -7 plus 7 is a 0. Now we've got to move across. -7 times -1 is a +7. And if I add +7 and 5, I get 12. It's okay if the numbers are starting to get a little large. It will work out in the end. And then -7 times -4 is a +28. And if I add 28 and a -4, I get a +24. All right, so I have my 1 in my top left entry. I have 0 in my bottom left entry. Now what I've got to work on is turning this 12 into a 1. And if I want to turn a value into 1, I multiply that row through by the reciprocal of the number that I'm trying to change. So I need to multiply 1/12 times row 2 to make my new row 2. Top row is still 1, -1, -4. Bottom row is 0, 1, and if I multiply 1/12 times 24, 1/12 times 24/1 becomes 2. My bottom row looks great because I have my 0 and my 1. Now I go back to the top row and I've got to get this -1 to become a 0. When I'm trying to get a 0, it means I multiply another row times something and add it to my row. Well, they've been very nice to us because notice if I just add these two rows together, that's going to give me 0. I don't even have to multiply the bottom row times anything. So if I add row 1 plus row 2, that becomes my new row 1. And that would give me 1 plus 0 is 1, -1 plus 1 is 0, and -4 plus 2 is a -2. And my bottom row is 0, 1, 2. Therefore, my solution is -2, 2. And again, if you want to check this, and that's always a good idea, pick one of your original equations. I'll take x minus y equals -4, and I want to plug in -2 for x, +2 for y. Check and be sure that this really is true. -2 minus 2 is a -4. So my solution checks. Now, again, you may want to pause this to make sure you get your matrix written out correctly. If so, you're going to discover when you come back that 10, 2, 3 should be the top row of your matrix. Your bottom row will be 5, 1, -1. Now, this is the first time that our top left entry has not been 1. And remember, if I want to turn a number into 1, I multiply by the reciprocal. I have to multiply everything in row 1 by 1/10, and that'll give me my new row 1. So 10 times 1/10 is 1. 2 times 1/10 is 2/10. And 3 times 1/10 is 3/10. Now, don't freak out over the fractions. They will eventually take care of themselves. All I'm concerned with right now is I do have a 1 in the top left of my matrix, so I'm ready to start looking at the second row, and I need to turn the 5 into a 0. If I'm trying to turn a number into 0, I've got to multiply another row times something and add it to the row I want to change. So that means I'm going to have to multiply the top row, row 1, by a -5 and add it to row 2 to get my new row 2. All right, top row is still 1, 2/10, 3/10. By the way, if you want to reduce 2/10 down into 1/5, that is perfectly okay. I'm just going to leave it as it is for right now. If I multiply the top row times -5, then I'm going to have -5 plus 5, which is how I get 0 for the first element. And by the way, these are called elements in the row. If I multiply -5 over 1 times 2 over 10, notice what's going to happen here. The -5 times 2 is a -10, and a -10 over 10 becomes a -1. Now be careful, because this -1 has to add to the +1 that we already had in this element here, and a -1 plus 1 actually becomes a 0. One more to go, because we have to take -5 over 1 times 3 over 10 And again, 5 would go into 10 two times. That gives us a negative 3 over 2, but we have to add it to the element that's already in row 2, which is a negative 1. And I could think of negative 1 over 1 as a negative 2 over 2, and that would give me negative 3 plus negative 2 is a negative 5 over 2. Now I've got an issue. This is something we haven't seen before. I know my goal is to end up with a 1, 0, 0, 1 on this left side in my matrix. But look what I have. I have a 0, 0 on the bottom row. And I am not going to be able to multiply through and get this second 0 that we just found to become a 1. In fact, think about what this means. This means 0x plus 0y would equal a negative 5 halves. Could that be true? Absolutely not. We've got 0 on the left side would be equal to a negative 5 halves on the right. Here's what that means. There is no solution. If you cannot come up with what's called reduced row echelon form, that's our 1001, reduced row echelon form. If we end up with a problem like this, where we get zeros where there should be ones, and we end up with a contradiction, there will be no solution. So just like we saw those in substitution and elimination, you are also likely to see them with matrices. Okay, let's look at this one. If we go to matrix form, we have 3, negative 15. 15's over on our solution side. And be careful on this second equation, because is it in standard form? Are the x and the y already on the same side? The answer is no. That's got to be rewritten before it can go into our matrix. So I'm going to have to subtract 5y from both sides, and I'll get x minus 5y equals 5. And now when I put it into the matrix, I'm going to have 1, negative 5, and then 5 over in the answer spot. Very important that you understand that you have to have it in standard form. The x's and the y's on the same side before you go into matrix form. Now, one of the things we can do, remember we said we can switch rows? Why don't we take row 1 and switch it with row 2? And that would give us our 1 in the top left. 1, negative 5, 5. Bottom row will be 3, negative 15, 15. Now we need to look at turning that bottom row into a 0. So in order to make that happen, we're going to need to multiply the top row times negative 3 and add it to our row 2 to get our new row 2. Alright, so top row is still 1, negative 5, 5. Now for our bottom row, we're going to have the negative 3 times 1 is a negative 3 plus 3, which is 0. If we do negative 3 times negative 5, that gives us positive 15 plus negative 15, which is also 0. And then if we multiply positive 5 times negative 3, that's a negative 15, plus positive 15 on the bottom, that's also a 0. Okay, we just saw this a moment ago where we ended up with a 0 in the place of where there was supposed to be a 1. But remember, if I pull this out and I write it with the variables back in, I have 0x plus 0y equals 0. That statement is true. It wasn't a contradiction. So The solution on this is not no solution. Instead, it will be infinitely many solutions. So just like we saw with substitution and elimination, we can have no solution or infinitely many solutions as we're working with these. Now I do need to show you something a little bit different. This one has fractions in one of the equations but not the other. Now what I can do is rewrite this top equation without the fractions. I can eliminate them if I multiply the top equation through by the LCD. In this case, the LCD would be 2. And that would give me 2y equals, when I multiply 5 over 2x times 2, that gives me 5x, minus 5 over 2 times 2 is 5. Bottom equation was 4x minus 6y equals 15. Now you should notice something. Is that top equation in standard form? No, it is not. So I need to put it in standard form. That means if I move the x term over, I will have negative 5x plus 2y equals negative 5. Bottom equation is 4x minus 6y equals 15. Okay, ready to go to my matrix. So I have a negative 5, 2, and a negative 5 on top. Second equation is a 4, negative 6, and 15. All right, my top left element is not 1, and it needs to be 1. So I have to multiply by a negative 1/5. Multiply everything in row 1 by a negative 1/5. Negative 5 times negative 1/5 gives me a positive 1. Positive 2 times a negative 1/5 gives me negative 2/5. And negative 1/5 times negative 5 gives me a positive 1. Make sure you keep up with signs. Bottom row has not changed. 4, negative 6, 15. Okay, my top row, I've got 1 in the top left corner, so I'm good. I'm ready to now look at the second row, and I need to turn that 4 into a 0. That means that I will have to multiply row 1 times something and add it to row 2. So what I'm going to do is multiply row 1 times negative 4 and add it to row 2 to get my new row 2. So here's what we'll end up with. Top row is still 1, negative 2/5, 1. Bottom row, when I multiply the negative 4 times 1, I get negative 4 plus 4, which is 0. When I multiply the negative 4 times the negative 2/5, you might want to do this on paper so you can see. A negative 4 over 1 times a negative 2 over 5 is going to turn into positive 8 over 5, but don't forget that we still have to add this to row 2, which is a negative 6. So we've got a positive 8 over 5 plus a negative 6 over 1. Again, we need a common denominator, so we're going to have to multiply that negative 6 over 1 times 5 over 5, and we're going to have 8 over 5 plus a negative 30 over 5. That will give us a negative 22 over 5. Be very careful. Okay, we're not quite done. Remember, we're still multiplying negative 4 times row 1 and adding it to row 2. So negative 4 times this last element, which is a 1, gives us negative 4 plus 15, and 15 minus 4 is 11. Okay, so far so good. We need to turn this negative 22 over 5 into a positive 1. And remember, the way you do that is you multiply times the reciprocal. So I need to multiply everything that's in row 2 by a negative 5 over 22. that will give me my new elements for row 2. So my top row is still this, hadn't changed. But my bottom row, negative 5 over 22 times 0 is 0. Negative 5 over 22 times negative 22 over 5 is a positive 1. Now I need to take a negative 5 over 22 and multiply it times 11 over 1. And 11 will go into 22 2 times. I get a negative 5 halves. Okay? Really close. Here's the only thing left to do. I've got to change this into a 0. And remember, to turn something into a 0, I'll have to multiply the other row times something and add it to my row. So I need to multiply it by in this case, I'll multiply it times a positive 2/5 because I'm going to multiply that 1 times a positive 2/5 to add to that to become a 0. So row 2 has to get multiplied by a positive 2/5. I'll add that to row 1. That becomes my new row 1. Okay, 2/5 times 0 is 0. 0 plus 1 is 1. 2/5 times 1 is 2/5, and 2/5 plus negative 2/5 is 0. 2/5 times negative 5 over 2 becomes a negative 1. But that still has to be added to the element that we have in row 1, which is a positive 1. And negative 1 plus 1 is 0. Bottom row is 0, 1, negative 5 halves. And we have our solution. It's the ordered pair 0, negative 5 halves. Two more examples, and then we will be done with this set. We'll just have one more practice round with a little more difficult matrices that we'll do. What we're actually doing is Gauss-Jordan elimination. We're using the Gauss-Jordan method for solving matrices. We're just working with simple ones in this one, and then we'll pick up the pace a little bit in the next one. Now, if you look at this, we've got a matrix of 3, negative 1, 4. Top row, bottom row is 1, negative 1, 2. All right, one thing I noticed that I can do is I can switch row 1 and row 2. And that would give me a 1 on my top left entry in this matrix. You don't have to do that, but that is something you can do. So now I'm ready to look at the bottom row, and I want to turn this first element, this 3, into a 0. So I'm going to multiply negative 3 times row 1 and add it to row 2 to get my new row 2. All right. Top row will not change. 1, negative 1, 2. But for the bottom row, I'm going to multiply negative 3 times 1. That's a negative 3, and negative 3 plus 3 is 0. Now I'll multiply the negative 3 times negative 1. That's a positive 3, and positive 3 plus negative 1 is a positive 2. Now I'll multiply negative 3 times positive 2. That's a negative 6. Negative 6 plus 4 is a negative 2. Okay. This 2 needs to turn into a 1. Do you remember how to make that happen? If I want to turn a number into 1, multiply by the reciprocal. So 1/2 row 2 will become my new row 2. 1, negative 1, 2, still on the top row. Bottom row, 0 times 1/2 is still 0. 2 times 1/2 is 1. And negative 2 times 1/2 is a negative 1. Almost there. All I have to do now is add row 1 and row 2 to get my new row 1. So 1 plus 0 is 1. Negative 1 plus 1 is 0. And 2 plus negative 1 is a positive 1. Bottom row is 0, 1, negative 1. And we have our solution now. It's the ordered pair 1, comma, negative 1. One more. And this one has fractions in both of the equations. So we know we need to eliminate those in the beginning. And the way we do it is we find the LCD. Excuse me. So if you look at your denominators, I have a 2, a 3, and a 4. And I could either get the LCD for all of these, or I can take the LCD just for the top fraction and the LCD for the bottom fraction. And if I do that, I will be working with a little bit smaller numbers. So the LCD on the top is 6. The LCD for the bottom is 4. So let's multiply everything in the top equation by 6, everything in the bottom equation by 4, and let's see what we have. 6 times 1/3 x is 2x. 6 times 1/2 y is 3y. And 6 times negative 3 is negative 18. So that's going to be our top equation. 2x plus 3y equals negative 18. Multiply the bottom equation by 4. 4 times x is 4x. 4 times negative 1/4 y is a negative 1y, so we can just write negative y. And 4 times negative 2 is negative 8. Okay, matrix time. We have a 2 and a 3 and a negative 18 in the top row, and a 4 and a negative 1 and a negative 8 in the bottom row. Okay. I think there's no point in switching these rows, but this first element is not a 1. So to make it a 1, I'm going to have to multiply everything in row 1 by 1/2. If I'm trying to make something 1, I'm going to have to multiply that row times something. If I'm trying to make something 0, multiply the other row times something and add it to the row you want to change. So 1/2 times 2 is 1. 1/2 times 3 is 3/2. And 1/2 times negative 18 is a negative 9. Bottom row has not changed yet. But we are ready to try to turn this 4 into a 0. So the way to do that is to multiply row 1 times negative 4 and add it to row 2 to get the new row 2. All right, top row is still 1, 3/2, negative 9. Now for the bottom row, we're going to multiply everything in this top row times negative 4 and add it to the bottom. So negative 4 times 1 is negative 4. Negative 4 plus 4 is 0. Negative 4 over 1 times 3 over 2. 2 goes into 4 2 times. That means negative 2 times 3 is a negative 6 plus a negative 1 turns into a negative 7. You probably want to put pencil to paper on that. Make sure you don't make any mistakes. And then negative 4 times negative 9 is 36. And then when we add 36 and negative 8, we come up with 28. So there's our new matrix. Time to turn negative 7 into a positive 1. That means I had better multiply the bottom row times negative 1/7. So negative 1/7 times row 2 becomes my new row 2. And I have 1, 3/2, negative 9 on top. 0 times negative 1/7 is 0. Negative 7 times negative 1/7 is 1. And 28 over 1 times negative 1 over 7. 7 goes into 28 4 times. That's a negative 4. My bottom row is done. Now, to turn this 3/2 in the top row into a 0, I'm going to have to multiply row 2 times negative 3/2 and add it to row 1 to get my new row 1. Okay, we're going to have negative 3/2 times 0 is 0, and 0 plus 1 is 1. Negative 3/2 times 1 is negative 3/2, plus positive 3/2 is 0, and negative 3/2 times a negative 4 over 1. 2 would go into 4 2 times. That's going to give me a positive 6. Negative 3 times negative 2 is a positive 6. But don't forget, I have to add negative 9 to that, and 6 plus negative 9 is a negative 3. Bottom row was 0, 1, negative 4. That means my solution is the ordered pair, negative 3, comma, negative 4.